All right, okay, let's go through this one then. So part B. I've taken a selection of questions. I've taken 3 questions. And effectively, it's a backwards question. So it's saying, here's a transformation matrix. Work out what the transformation is. So I think what we need to do here is we need to draw this out. So we need to say, right, this thing here corresponds to where I ends up, and this thing here corresponds to where J ends up, and then we can see what happens. So we can see what the transformation is to get us from here to here. So okay, let's draw this. Looks like it, yep. So I has ended up at negative 1, 0. So I has ended up at negative 1, 0. So it ends up over here, okay? And J has ended up at 0, 1. In other words, it hasn't moved. So J ends up here, okay? So what is the transformation that gets me from here to here? What's happened here? It's a reflection, right? A reflection in which axis? It's the y-axis. Good. So how I would describe this matrix is it is a reflection in the y-axis. Okay? That's what this matrix corresponds to. Can you see what we're doing here? We're just simply drawing out where I and J end up, and then we work backwards. We say, what is the transformation that's happened? Let's do the same thing here then. You might be able to see. Sorry? Okay, fine. So I, remember I is the first one, I ends up at 4, 0, which is like way out here, right? Way out here, okay? And J has also been moved, so it's now at 0, 4. Okay, so again, it's like the same distance from 0 as I is. So what is the transformation to get us from here to here? It's a stretch, an enlargement, by what scale factor?
It's a 2.
4, isn't it? Because it's gone from 1, 0 to 4, 0, and that's gone from 0, 1 to 0, 4. Okay, so it's been stretched. It's an enlargement in both directions by a scale factor of 4. Okay, so make sure you write the word enlargement as well, because we tend to reserve stretches for just in one direction, so either x or y direction. This is happening in both directions, so it's an enlargement. So it's an enlargement by a scale factor of 4. Okay, center origin, I should put. Okay, so centered at the origin. So it's basically like saying, put your finger there and stretch the entire thing outwards by 4. Let's finish off on this one then. So we got 3, 0 and 0, 6. So what's happening here? Okay, so here's I. I was at 1, 0. It's now ended up at 3, 0. Okay, there's I. So what are we thinking about with I? Yeah, good. It's a stretch in the y direction, sorry, the x direction by 3. What about J, boys? Sorry. What about J? Good, yeah, it's ended up way up here. Okay, so actually there's 2 transformations that have happened here. They're both stretches. We've gone a stretch in the x direction by a scale factor of 3. But we've also done a stretch in the y direction. And that's been scale factor of 6. Okay. So can you see it's really important to draw the sketch? It's simply asking the question, well, where does I and J end up after we've applied the transformations? Okay. So you're happy with this? You're happy you can do it both ways? So I give you the transformation matrix, you tell me what the transformation is, like we're doing here. But also I give you the transformation, and you tell me what the transformation matrix is. Can you do it both ways? Which way do you think is easier? This way, so I give you the transformation matrix, you tell me the transformation, or the other way, I give you the transformation, you tell me what the transformation matrix is. The first one, right? Or the second one? This one?
I think this one is.
The other one that we were doing before? Yeah. So I give you the transformation and you tell me the transformation matrix. I agree with that. I think that's easier. However, it's not impossible to do it this way. Yeah. Okay? Just make sure you do your sketches. Okay, good. We'll finish off there.